So looking here, how can we relate what we did with the die to where it says 3 to the 4th times 3 squared? How does that relate? How does that whole piece relate back to what we did on Friday? Drew.
One dice was the base, which is 3, and the other 2 dice is the 4 and 2.
Absolutely. So one die represented our base, and then another die represented our first exponent, and then our second exponent. Okay. What about the second step? Why did I expand it like that? Someone explain to me why it says like all those 3s in a row like that. What does it mean? Dalen.
They're writing it in expanded form.
It is expanded form. Very good. So 3 to the 4th really means 3 times 3 times 3 times 3. And since we're still dealing with multiplication, since it's 3 to the 4th times 3 squared, then I do 3 times 3 times 3 times 3 times 3 times 3, which all together, when lined up in a row, and we count them, gives me 3 multiplied by itself 6 times, which essentially we can write as 3 to the 6th power. Okay? We all okie dokie there? It's kind of slowly coming back to us. All right. So let's fill out this definition. So it says a monomial is a number, a variable, or a product of blank and or blank. So if you can see here, I have examples of monomials. And we have an example of a monomial is 80 or x or 8x. So a monomial is a number, a variable, or a product of numbers and or variables. One second, babe. Okay, so see here, we can see an example where it says 4 to the 3rd times 4 to the 5th. And then equals, so now I'm going to actually do the computation. I still have my base. My base is 4, so my base doesn't change. And then I have to add my exponents, 3 plus 5, so I end up getting 4 to the 8th. We all right?
Yeah.
Okay. Second example, and it didn't print out all the way. It stinks. I have 6 times 6 to the negative 4th. What does that first 6 have that we don't see? It has an exponent, but what is that exponent that we don't see? Dylan?
The 1.
A 1. And when you don't see it, I always recommend to write it in there because it's just good. It's good habit. And on top of it, when you go to do the math, you won't forget that there is a 1 there. Now, we still add. So we do 1 plus a negative 4. Well, 1 plus negative 4 gives me 6 to the negative 3rd. Am I happy with that answer? I mean, not that it's wrong. This is not a wrong answer by any means. But that's what I call my B answer. Because I wouldn't mark you all the way incorrect, but I would take a couple points off for a particular reason. And what is that reason, Autumn?
The exponent is still negative.
Yeah, the exponent is still negative. Do I like negative exponents? No. So we have to turn around and make it positive. So that's why my final answer, my A answer, is going to be 1 over 6 to the 3rd. Okay, what I would like you to do is take like a minute And do 1, 2, and do examples 1, 2, and 3, and then we're going to go over them. Let's take a look at the first one. I have 5 squared times 5 to the third. Is my base the same, and if so, what is it? What is my base here? Is it the 5, the 2, or the 3? Dalen? It's the 5. So since I have the same base, I'm going to write that. And I need to add my exponents. 2 plus 3 gives me 5. So my final answer is 5 to the 5th. Twelve to the third times 12 to the negative second. Is my base the same? What is my base, Ashley? What?
12.
12. Okay. And then what is 3 plus a negative 2? Because we have to add our exponents. Go ahead.
1.
It is 1. Very good. You could write it like this. You could also simply just write it as 12. They both mean the same exact thing. You don't have to erase it. You don't have to. I wouldn't take any points for it. I'm just saying you could write it that way as well.
Can you write it as a fraction?
Well, you wouldn't write it as a fraction until you were all done. So if that was like a negative, if that was 12 to the negative 1, then it would have become a fraction. But because that's a positive 1, you don't have to do anything with it. Okay? Okay. What's my base? Okay, so my base is 4. I have to add my exponents. So I get 2 plus a negative 2. So what do I get? 0. That's my B answer. Why is that my B answer? We're going way back, like 2 weeks. Why is that my B answer? What is 4 to the 0 power? I hear rumblings. What? 1. Because anything to the 0 power is 1. All right, please notice that it says, watch out. When multiplying powers, do not multiply the bases. It's a super common mistake that people make. You are not going to multiply 6 times 6 to get 36. Your base simply stays the same. If your base is 6, then your answer will have a base of 6 as well. Okay? Super common mistake. Happens a lot. What we do with numbers, we can also do with variables. So my base can be a variable just as it is a number. Reed, what is my base here?
B.
My base is B. Okay, so what do I have to do to my exponents, Reed?
Have to add them.
All right, so after I add them, what's my answer going to be?
4.
So my answer is B to the 4th. Okay. Leah, what is my base for the next one?
1.
Just go straight across. We're at B.
Oh, 2.
Okay. I'm going to add my exponents. What is a negative 5 plus 3?
Negative 2.
Very good. This is my B answer. Why is this my B answer, Leigh?
I don't know.
Someone help her out. Go ahead, Autumn.
The exponent's still negative.
Mm-hmm. Negative exponents create, what's that R word? Reciprocals. So I need to send this to the bottom, so I end up getting 1 over 1 over t squared. Okay? Go ahead and do the bottom row, and then we'll go over them. All right, go ahead, draw. What's my answer for A?
Oh, y with the exponent of 9.
Very good. Y to the 9th. So my base is y. My exponents are 6 and 3, and I must add them. So I get y to the 9th. Dalen, go ahead.
R with the exponent 1.
Bless you. Good. R to the first, because I'm going to add 6 and negative 5. 6 plus a negative 5 gives me a positive 1. So I leave it as R to the first, or simply just R. Either way, I don't really care. Okay?
So you grade this too? No.
I'll grade the paper.
Oh, the paper. You got any more papers for tomorrow?
Lake, go ahead. What's my base?
A.
Okay, so my base is A. What am I going to do to my exponents?
Add is 13.
That's your son name right there. Aiden.
What?
Is that your son name up there? Never mind, it's off top.
Okay. Autumn.
4 negative.
So my base is X. My exponent is negative 4. I love that. Am I done?
No.
No. Why am I not done?
Because of exponent negative.
Because I have a negative exponent, which tells me to do what, Ashley? What's that word?
Reciprocal.
Reciprocal. Good. So the reciprocal is what, Autumn?
X is a positive.
1 over x to the 4th. Go ahead. In a minute.
This is getting harder. Like, I don't know which way, but that's what I'm trying to do.
Okay. So now this is a little, we're taking what we did and we're going to take it a step farther. So flip her on the back side of the page right now. Okay. Notice that I have, so I've given you instructions. It says find each product, express using positive exponents. So now, notice that we have a couple different things here. First, we have numbers in front of our variables. We call them what? It starts with a C.
Coefficient.
Coefficient, very good. So I'm going to highlight or circle or do something. If you have colored pencils, they're going to pull them out real quick. So our coefficients are those numbers right there, which means that what is my base out of this? What is my base out of this going to be? Kayla, what's my base? The x's, very good. So these are my bases. Now, what I need to do, you can see that I gave you the instructions. We multiply our coefficients, okay? The only extra step we're doing here is we're multiplying our coefficients. So we multiply the 2 and the 8. Okay? And then you'll see here's my base, and then we add our exponents. Two times 8 is 16. 3, my base is x. I'm going to add my exponents. 3 plus 4 gives me 7. And then I can mash it all together and get 16x to the 7th. Are we okay? Do you want me to go through it one more time? Did you guys follow along with that? You sure? That is not a convincing look, Drew.
Oh, you're looking at big one.
All right. So the coefficients are the numbers in front of the variables. So we need to make sure that you're keeping those separated. Let's look at example B. Okay? Wow, I really screwed that up, didn't I? And we'll see who catches the mistake when we get there. Okay, so again, let's go out with the highlighter. My coefficients, I'm going to highlight. So those are my coefficients. My base is the variable. So I multiply my coefficients, which gives me 3 times 2, which will give me 6. Okay? My base is n. Because notice, how do we know that my base is n? There's one giveaway that tells me that my base is n. What would that giveaway be? I mean, just looking at it, looking at this one, looking at your example A, what is the giveaway? Why does it make sense that my base is not 3 and 2, or my base that is not 3 and 2? Drop.
One on top of it.
Right, because they don't have any exponents. Here, these are different numbers. Here, you see, I have n and n. I have bases with exponents. So we know that that's what's taking we're doing the law of exponents for multiplication. Okay? So that is my base, and I'm going to add my exponents. Negative 9 plus 8 gives me n to the negative 1. I can't leave my answer like this. I cannot leave my answer as I cannot leave my answer like that. Why can't I leave my answer like that? Because I have a negative exponent, and negative exponents create reciprocals. I created a reciprocal, but what did I not do? I did not turn it into a positive. Once it goes into a reciprocal, this becomes a positive one. So my answer really should look like 6 over n to the first. Correct, so we have to change it. All right. Try these 4. I'll give you a few minutes. Use your calculators and make sure that you're putting... Now, do you think that you're going to be able to put 5a squared into your calculator? No, you're using the calculator to do the multiplication of the coefficients. Okay? All right, go ahead. And I will post this video up on iTunes U so that way you have it as a reference. So if you get home and you're like, I have no idea what that one was talking about, or don't remember, then you can go back and you can watch the video. That's why I put them there. Okay. So another thing that I like to do, or a way that I like to draw it out, is that go like this, little rainbow up top, multiplication. Underneath, addition. So we're going to multiply 5 times negative 3. Gives us a negative 15. My base is a. And we're going to add the exponents. 2 plus 4, which gives me 6. Confusion? We okay? All right, let's look at the next one. Okay. Multiply our coefficients. 6 times 2 is 12. Our base is b. Add our exponents. -4 plus 2 is a -2. Again, this is not incorrect, but this is our B answer. I want the A answer. What does my A answer look like? What stays and what goes? What's staying up top and what's moving to the basement?
It will look like 1 over b.
What does that coefficient have? What does, again, I can expand this. So look at your example. Go up and look at your example for 3. What did we do? When I had 6 to -1. Again, you have to understand that I give you these problems knowing that you have examples up in the top. Knowing that you have examples up top. So I have an example just like this up top. What do I have to do? What stays and what goes?
The 12 will go up top and the b to the second power will go to the bottom.
Correct. So I'm left with 12 over b squared. C. I'm going to multiply my coefficients. Maybe not. Out on me this year. I know. 6 times 3 is -18. My bases. Add my exponents. 3 plus 5 is 8. Last one. Multiply the coefficients. 10 times 5 is 50. N is my base. I'm going to add my exponents. 7 plus 2 gives me n to the 9th. Okay? Your homework, again, is this independent practice at the bottom. You can do the work in a notebook or Notability. I will check tomorrow. Again, the video of today